Assume that the curve C has the equation y equal to x squared minus 2x minus 24 to the square root of x for x is more than 0. We first want to find the derivative. So we find dy dx, right? Okay, before that, we want to create this function into a ready form. What is the ready form? Let's say x squared minus 2x minus 24, square root of x, for your information, is x to the power of half. So, x to the power of half, right? So, then we can derive dy dx. Just use the power 2x minus 2 minus 24 multiplied by half is 12x negative half. Or you can write as 2x minus 2 minus 12 over square root of x. Since x negative 1 half equals to 1 over square root of x. Okay, now for 2, I want to find d2y, the second derivative, dx squared. Okay, we just easily derive the function again, right? 2, the derivative of 2x is 2, derivative of negative 2 is 0, derivative of negative half to the power of negative 12 to the power of negative half, negative 12 multiplied by negative 1 over 2 is 6 plus 6, x negative 1 over 2 minus 1 equals negative 3 over 2. Negative 3 over 2. Or you can write it as 2 plus 6 over x power 3. Okay, for B, verify that C has a stationary point when x equals 4. So we input x equals to 4 here. So 2 plus 6 divided by... No, wait. We put x equals 4 here. X equals 4. Right? So 4 minus 2 minus 12 divided by square root of 4. If you input it into a calculator, you will get 0. Therefore, because the derivative is the slope of a line, when the slope of the line equals to 0, that means it's at the stationary point. Stationary point, right? Yes. Okay, therefore it's stationary point. Now we want to determine the nature of this stationary point when x equals 4, right? And give a reason. So we use the second derivative test where we have already gotten the second derivative, and then we input 4 in there, right? 2 plus 6 square root of 4 to the power of 3. You get 11 over 4, which is more than 0, and therefore it is the minimum point. Because when it's more than 0, remember the happy face, we have a minimum. Okay, moving on to another question. The curve C had the equation y equal to 3x power 4 minus 8x power 3 minus 3. First, we find dy dx. Pretty simple, just use the power rule. Right, afterwards, we find d2y, the second derivative, basically. Alright, now verify that C has a stationary point when x equals 2, right? So we let dy dx equals 12 2 cube minus 24 2 square. What do we get? We get 2 power 3 24 2 square, and we get 0. Therefore, stationary point. C. Determine the nature of this stationary point, giving a reason for your answer. Now, for x equals 2, we can use the second derivative, right? So, 36 2 square minus 48 2 equal to which is more than 0, and thus it is also a minimum point.